Hi and welcome to Rational Expressions Day 10. This is the last set of new notes you'll have for rational expressions. And today we're going to solve fractional equations or solve rational equations. Some people call them fractional equations because it's the equations with fractions in it, or rational equations because, again, fractions. So to solve fractional equations, the first thing you're going to do is factor your denominators. Then you're going to find your LCD, and just like with the complex fractions, you're going to multiply every term by the LCD to get rid of the denominators. Step 4 is to solve, and then last but not least is your favorite thing to do, and that is to check. So, number 1, my LCD is 3C because I have LCDs of C, or denominators of C, 3C, and C. So I need to multiply every term by 3C. So in the first fraction, the C's cancel out, and I'm left with 3 plus. In the second fraction, the whole thing cancels out, so I'm left with 1 equals, in this fraction, the 3's cancel out, I'm left with 2C. So I just solved my equation. 4 equals 2C. So C is equal to 2. And that is fine and dandy. Let's do a little check. So we have 1 over C plus 1 over 3C equals 2/3. Well, that's strange. Let's see here. There we go. There's my 2/3. So I'm going to put in 2 everywhere I see a C. So I have 1/2 plus 1 over 3 times 2 is 6 equals 2/3. And in order to add fractions, you have to have a common denominator. My common denominator is 6, so 1/2 changed to 3/6 plus 1/6 is equal to 2/3. 3/6 plus 1/6 is 4/6 equals 2/3. And 4/6 reduced to 2/3 is equal to 2/3. So it checks, and we are good to go. For the next problem, I have x over x plus 3 equals 8 over x plus 6. My LCD is x plus 3 times x plus 6. So multiply each term times x plus 3, x plus 6. So in my first fraction, the x plus 3's go away, and I'm left with x times x plus 6. In my second fractions, the x plus 6 canceled out, so I'm left with 8 times x plus 3. Now, I just need to solve my equation. So we'll have x squared plus 6x equals 8x plus 24. Because I have an x squared term, I want to get it equal to 0. So I'm going to subtract the 8x and the 24. So I have x squared minus 2x minus 24 equals 0. So now I need to factor that. What are my factors of 24? That when I subtract, I get 2. Well, that would be 6 and 4. And the larger number takes the sign in the middle, so it's minus 6 plus 4. So x equals 6, x equals negative 4. Since I have 2 answers, I technically have to have 2 checks. So if I'm going to check when x equals 6 first, so 6 over 6 plus 3 is 9 equals 8 over 6 plus 6 is 12. I'm just substituting into the original equation for 6 for x. So if I reduce these by 3 on the left, I'll have 2/3. And if I reduce that fraction by 4 on the top and bottom, on the right hand side, I end up with 2/3. So my check works. And then I need to check -4. So I will have -4 over -1 equals 8 over 2. So this becomes 4 equals 4. They both check out, so they are both my answers. So 6 and -4 both work. Up here, the 2 worked. Okay, for number 3, I have y minus 7s and 2s in my denominator. So my LCD is 2y minus 7. So multiply everything by 2, y minus 7. And again, you have to do that for every term. I know that it gets kind of cumbersome and it's a lot to write, and you guys don't like to show work and all that good stuff, but I promise you in the end, if you do it this way, you will have better results in that you won't forget things or leave things out or forget to cancel something someplace else. So in the first fraction, y minus 7's cancel out, so I'm left with 6y. In the next fraction, the 2's cancel out, so I have to keep my -3, and then the y minus 7 equals here, y minus 7's cancel out, so I'm left with 42. So I solve my equation, 6y minus 3y plus 21 equals 42. Mind my like terms, I have 3y plus 21 equals 42. Subtract 21, so 3y equals 21. Divide by 3, so y equals 7. So here we go, our check. Y is 7, so 3 times 7 is 21. Over 7 minus 7 is 0. Minus 3/2 equals 21 over 7 minus 7 is 0. Okay? Yikes. Cannot have zeros in the denominator. Therefore, that's what these 3 little dots mean, is therefore we have no solution. Because the one answer that we got gave me undefined values. Therefore, once it's undefined, it can't be a value that works for our equation. So in this case, we have no solution. So we have to go back to the 7, and we need to reject it. And this is what we call an extraneous root. We call it an extraneous root. We remember what extraneous root means by the word extra in extraneous. So it's an extra root, meaning we get an answer when we solve the equation. However, that answer isn't going to be valid because it makes our fraction undefined. Therefore, we had an extra root. It didn't work. Another way to denote no solution would be a 0 with a slash through it, which means an empty set, or fancy brackets that are empty. You cannot take that empty set symbol 0 with the slash and put it into the brackets, because then your brackets are no longer empty, even though they have the empty set in it. It's just kind of crazy. They need to be empty to be considered an empty set or no solution. So let's try the last one. For number 4, the x squared minus 64 did factor, and that became x plus 8, x minus 8. So I need to multiply every fraction by x plus 8, x minus 8. Again, I know it's a lot of writing, but in the long run, I think you'll be happy that you did it. So here the x plus 8's cancel out, and I'm left with x times x minus 8 Here, everything goes, so just plus 16 equals the x minus 8's cancel, so I'm left with x plus 8. So just solve this equation. I have x squared minus 8x plus 16 equals x plus 8. We'll subtract the x, subtract the 8. So I have x squared minus 9x plus 8 equals 0. So I need to factor that. And my factors that 8 that add up to 9 are 8 and 1. Last sign's positive, so my signs are the same. Take the sign in the middle, so they're both negative. So x equals 8 and x equals 1. Go to do our check. This time we have two checks. So if x is equal to 8, I'm going to have 8 over 8 plus 8 is 16 plus 16 over, if I put 8 in, I get 64 minus 64, I get 0, equals 1 over 8 minus 8 is 0. Once I see that, I can stop. I know that 8 is not going to work, so I'm going to just go back over here and reject the 8. And then I also need to check when x equals 1. So I'll have 1 over 1 plus 8 is 9, plus 16 over 1 squared is 1, so 1 minus 64 is a negative 63, equals 1 over 1 minus 8 is negative 7. So in order to add my fractions, I have to find an LCD. And an LCD for 9, 63, and 7 would be 63. So I need to multiply this by 7, nothing here, and this one by 9. So I have 7 over 63 minus 16 over 63 equals, since that's negative, we'll make the whole fraction negative. 9 or negative 9 over 63. And 7 minus 16 is negative 9 over 63 equals negative 9 over 63. So that works. Therefore, my answer is x equals 1. Once you get rid of the fractions, you solve this like you would any other equation that you know how to do. Getting rid of the fractions is just like we did with the complex fractions. So you're kind of taking two concepts and putting them together to help you solve here. All right, just to see if you made it to the end, put a smiley face on the bottom right-hand corner of this last page of notes.